Welcome to the DIY Honda Garage channel. The diagnostic trouble code DTC P1172 indicates an issue with the air-fuel AF sensor, specifically sensor 1, which is crucial for the accurate monitoring of the air-fuel ratio in the engine. This sensor is located in the exhaust manifold before the catalytic converter. It plays an essential role in determining whether the engine is running rich or lean, feeding this information to the Engine Control Module, ECM, sometimes referred to as the Powertrain Control Module, PCM. A reading that is out of range high could signal that the sensor is over-reporting the amount of oxygen in the exhaust, leading to adjustments that may cause performance issues. Before delving into the troubleshooting steps, it is advisable to record any freeze-frame data and onboard snapshots, providing vital clues regarding the conditions under which the error occurred. This ensures a methodical approach to resolving the issue, avoiding potential misdiagnosis. The AF sensor 1 is the first sensor in the exhaust stream that measures the ratio of air to fuel in the combustion process. Its location is critical as it is positioned in the exhaust manifold, which allows it to accurately monitor the exhaust gases before they enter the catalytic converter. This component feeds real-time data to the ECM, enabling it to adjust fuel injection and ignition timing to maintain optimal engine performance. If the sensor's readings are high, it could lead to a rich fuel mixture, affecting fuel economy and engine performance. By understanding its role, one can appreciate the importance of addressing the DTC P1172 promptly to prevent further engine issues, including potential damage to the catalytic converter caused by incorrect fuel mixture adjustments. There are several possible causes for the appearance of DTC P1172. One common issue is a faulty AF sensor, sensor 1, which may be providing inaccurate readings due to internal failure. Wiring issues can also contribute to this error, particularly if there are short circuits, frayed wires, or poor connections between the sensor and the ECM-PCM. The ECM-PCM itself could malfunction, leading to incorrect processing of sensor data. Other elements, such as environmental factors, including high exhaust temperatures or contamination, might also affect the sensor's performance. By systematically examining these causes, one can narrow down the specific issue responsible for triggering the DTC. Drivers may notice several symptoms if DTC P1172 is present. An increased fuel consumption rate often manifests, indicating that the engine is running richer than necessary due to erroneous sensor readings. This, in turn, can lead to poor engine performance, making acceleration sluggish and potentially causing stalling issues. Engine misfires may also occur as the air-fuel mixture is unable to ignite properly, leading to rough idling and performance inconsistencies. Additionally, the check engine light may illuminate on the dashboard. Being aware of these symptoms allows for early diagnosis and the prevention of more severe issues that could arise from continuing to drive with a faulty AF sensor. The first step in troubleshooting DTC P1172 is to engage the ignition system by turning the ignition switch to the on position, specifically to the II setting. This action powers the vehicle's electronic systems and prepares the onboard diagnostic OBD system to perform checks. It is essential to avoid starting the engine at this point, since further steps require the ignition system primed, but without the engine running. Performing initial checks while ensuring all systems are operational is crucial for accurate diagnostics, as it sets the stage for subsequent actions, including clearing diagnostic trouble codes. In the second troubleshooting step, you need to clear the existing DTC using the Honda Diagnostic System HDS. The HDS is a specialized tool designed for Honda vehicles. allowing technicians to access detailed diagnostic information. Clearing the DTC is a critical action as it resets the system and removes any stored fault information. This process helps determine if the issue is persistent or intermittent. Following this step, the system monitors the vehicle's performance to ascertain whether the same code reappears, thereby aiding in identifying whether the A-factor sensor issue is ongoing or was a temporary anomaly. After clearing the DTC, it is essential to start the engine and hold the engine speed at approximately 3,000 revolutions per minute, RPM, without load, i.e. automatic transmission in park or neutral, manual transmission in neutral. This step is crucial as it allows the engine to reach its operating temperature and for the radiator fan to activate, resulting in a proper diagnostic setup. Maintaining this speed ensures that the conditions are optimal for the AFAT sensor to report accurately. This step also allows the technician to monitor sensor readings effectively and assess the status of the DTC, providing a clear understanding of whether the AFAT sensor is functioning as it should. In the fourth step, it is imperative to monitor the onboard diagnostic OBD status using the Honda Diagnostic System, HDS. This monitoring enables you to determine the current status of DTC P1172, as it varies between passed, failed, and executing. If the status indicates failed, it signifies that the sensor is likely malfunctioning and requires attention. However, if the system shows passed, it suggests that conditions have temporarily improved. While executing means the system is still processing data. Monitoring the status gives crucial feedback about the condition of the AF sensor and indicates the next steps for troubleshooting, whether to proceed with repairs or continue monitoring. If the OBD status indicates a failed condition for DTC P1172, the next step is to turn the ignition switch to the lock position, specifically to 0. This action completely power downs the vehicle's electrical system, which is essential for ensuring that the system resets and prepares for the next phase of troubleshooting. By locking the ignition, it helps clear any temporary faults or glitches in the system that may have been inadvertently caused by prolonged operation. Once the ignition is locked, further actions, such as component replacement, can be carried out with minimal risk of electrical shock or faulty readings. Following the ignition lock, Step 6 entails replacing the faulty AF sensor, Sensor 1. Given that the DTC P1172 indicates issues with this component, replacing it is a direct approach to resolving the code. The sensor should be located in the exhaust manifold, and it's important to ensure that the replacement sensor is compatible with the vehicle's specifications. After reinstalling the new sensor, meticulous attention should be given to connections, ensuring no loose terminals or damaged wiring that could lead to further erroneous readings. This replacement is crucial as it restores the ability to correctly monitor the air-fuel mixture, directly impacting engine efficiency and performance. Once the AF sensor has been replaced, you should again turn the ignition switch to the on position, specifically to the 2 setting. This action powers the vehicle's electronic modules and prepares the system for further diagnostic evaluations. At this point, ensure all electrical connections related to the new sensor are secure. Engaging the ignition without starting the engine activates the onboard diagnostic systems in order to prepare for evaluation of the new sensor's functionality. By entering this step, you are paving the way for resetting the ECM/PCM, which is crucial for freshly integrating the new sensor into the system. Step 8 involves using the Honda Diagnostic System, HDS, to reset the Engine Control Module, ECM, or Powertrain Control Module, PCM. Resetting the ECM-PCM is essential following any component change, such as the A final F sensor, as it clears any previous fault codes from the vehicle's memory and refreshes the system's logic. This process helps relearn the vehicle systems to accept the new sensor input accurately. It's a critical step because it ensures that defective readings do not persist due to outdated data in the control module. Once the reset is complete, monitoring the sensor's performance becomes imperative. After resetting the ECM-PCM, the ninth step is to execute the idle learn procedure. This procedure allows the ECM-PCM to recalibrate itself to the new operational parameters established by the replaced AF sensor. Proper idle learning is essential for the engine control unit to correctly manage fuel injection and air intake based on real-time sensor data. If this step is overlooked, the engine may not achieve optimal performance, leading to stalling or inconsistent power delivery. The idle learn procedure ensures that the ECM has accurately adjusted to the correct engine idle state, accommodating for any changes due to the new sensor. In the 10th step, start the engine again and hold it at approximately 3,000 RPM without load, similar to previous procedures. This step is vital for allowing the new AF sensor to relay accurate data back to the ECM-PCM, confirming that it is functioning as intended. Holding the engine at this specific RPM allows the system to observe the sensor's response under consistent conditions, including evaluating its readings in relation to the exhaust flow and overall engine performance. As the radiator fan engages, it offers an additional condition that helps in validating sensor accuracy. Continuing to monitor the vehicle's behavior throughout this stage assists in confirming the effectiveness of the troubleshooting steps taken up to this point. Upon completing the above steps, it is crucial to verify the status of the DTCs via the HDS in Step 11. Check for both pending and confirmed DTCs to establish whether DTC P1172 still appears after all corrective measurements have been implemented. If the code is re-identified, it indicates that underlying issues such as loose wires or poor connections exist between the AF sensor and the ECM-PCM, necessitating further investigation. Conversely, if DTC P1172 is not present, it suggests that the repairs have been successful, resulting in the accurate functionality of the new sensor. This step is pivotal for determining if additional troubleshooting for other DTCs is necessary. The final troubleshooting step involves monitoring the OBD status through the HDS once again, similar to previous evaluations. If the screen indicates that DTC P1172 has passed, it signifies that the system is operating correctly and repairs are complete. If any other pending or confirmed DTCs were indicated in Step 11, those specific codes will then require troubleshooting. It is essential to ensure there are no lingering issues that could affect vehicle performance or emissions. If DTC P1172 has failed again, a thorough investigation into connections between the AF sensor and the ECM-PCM should occur. The system's enduring status gives the vital feedback needed for the technician to confirm that all repairs have been successful. Final verification of repairs concerning DTC P1172 involves ensuring that the newly installed AF sensor is operating correctly. This involves checking for a successful flow of data back to the ECM-PCM without the reoccurrence of DTC P1172. It is equally important to check that all electrical connections are secure and free of corrosion or damage. Any identified issues at this stage require immediate attention before considering the troubleshooting complete. A thorough test drive should be conducted to observe real-world performance, ensuring the engine runs smoothly and that there are no lingering signs of malfunction. Completing this verification step guarantees that the vehicle is in optimal working condition and safe for use. To prevent future occurrences of DTC P1172, especially concerning the AF sensor, regular maintenance is paramount. Routine checks of the AF sensor can identify early signs of wear or failure, allowing for proactive replacement before a fault code appears. Additionally, inspecting the associated wiring and connections ensures that any potential damage can be addressed swiftly. Maintaining a consistent schedule for vehicle services, including oil changes and component inspections, enhances overall vehicle reliability and performance. By taking these preventive measures, vehicle owners can minimize the risk of sensor-related issues and ensure long-term functionality. In summary, understanding DTC P1172 is essential for maintaining the performance and efficiency of the Honda Civic from 2006 to 2011. The AF sensor plays a vital role in managing the vehicle's air-fuel ratio, directly impacting engine performance, fuel economy, and emissions. When this sensor fails or provides incorrect readings, it can trigger operational issues, leading to lower performance and increased emissions. Following the detailed diagnostic steps ensures a methodical approach to identifying the problem, replacing the faulty component, and verifying that the repairs have resolved the issue effectively. Lastly, instituting regular maintenance measures helps prevent similar issues from reoccurring, leading to a vehicle that runs smoothly and efficiently. Please like and subscribe to the channel. See you next time.